So let's just say you've got an iPod.
Change the letter in the
Yeah, that band's terrible. They throw soda everywhere.
Oh crap! You told me about. I'm sorry. You told me about those guys, Maddie. I'm sorry.
Are
So
you
we got
in
an
trouble?
iPod with 10 songs. Sorry. We got an iPod with 10 songs. Let's say you do shuffle.
Juggalo for life.
Sorry.
Down for clouds,
Sorry.
ground.
Exam practice. There we go. So number one, let's say for all of these you play exactly 10 songs. Okay, so you hit shuffle and you play exactly 10 songs. Now the definition of shuffle means you're going to get every song exactly one time. That's what the definition of shuffle on an iPod means. I don't know if it means that for every single MP3 player device, but it does mean that on an iPod. It's kind of a nod to the idea of shuffling a deck of cards. Shuffle a deck and then deal them out. You get one card one time. And if you deal the whole deck, you've got 52 cards out. Each one shows up one time. So, but let's just, for the point of argument, what's the chance? Or how many ways? How many 10-song playlists, which is what you would have if you played 10 songs, 10-song playlists, can there be? And we'll do number 1A, if songs can be reused. Or number B, or whether it's letter B, songs can't be reused. And B is the actual definition of a shuffle. You don't reuse the songs. And Penelope has answered part A for us already. You put the lines out. You put the lines out. Okay. You got 10, 10, 10, 10. I mean, it looks just like the phone number problem from class on Tuesday. Thank you. 10 million. That's a million, isn't it? A few more zeros. There we go. Please!
Would it be too short, 10 to the 10?
Yes, of course.
That's a lot of zeros with that would
Sure.
be.
10 to 10 is fine. That's equivalent. Sure. That's fine. No problem with that at all. Oh, there's actually shorthand for the next one, too. This is going to be fun. There's shorthand for the next one as well. So, what if they can't be reused?
10 times 9 times 8, 7 times 6 times 7 times 4 times 3 times 2 times 1.
I think I will find out here in a second. You got 10 choices for the first song, one of which is correct, like 99.
Oh.
Now, if you hear it once, you can't hear it. That's an awesome sound effect. You go, like,
Oh.
you can't hear it. You can't hear it again, so you're down to 9. Then you can't hear either of those, so you're down to 8, and it's going to keep on going. And that actually, I don't know what that exactly equals because I can't do it in my head. But 362888800. So boom, boom. 3.6 million. Okay? This actually has a shorthand too. It's called a factorial. 10 exclamation point. That's the short. If you want to use shorthand, that's totally fine. That's it. It's bang. 10 bang. That's I didn't think it that way rather than factorial. Bang. And that's all it means. It means start with 10 and multiply down to 1. That's all it means.
Bang.
10 bang. And the reason I mention this, Apple had to deal with this back in the day. Speaking of prints or songs on your iPod that you might or might not want. People, you express your opinion very, very guy, love this guy. People were complaining that they were getting too many of one artist on their iPods. Did I tell you this before? Like they were saying things like, I'm getting too much. I told 5 times already. I've looked for it 5 times already. All right, at least 5 times. Anyway, that's the mathematics. I'll stop telling it 6 times. That's the I've seen it now 5 times on YouTube. Sorry, YouTube. But anyway, this is the mathematics you have to do to analyze the chance of that happening. It's actually pretty good. Think about it. What's the chance if you play 10 random songs out of the 10 on your iPod that all the songs are different? What's the chance you get 10 unique songs? So, imagine the iPod has a shake to shuffle feature, which if you start playing it and you shake it, if you have it turned on, it'll re-randomize the playlist. So that's how you could actually get 10 print songs. You could shake it, hear Prince, shake it, get Prince again, shake it, get Prince. I mean, theoretically, you could. You can't. Yes, Gabe, I use like the iPod. But theoretically, you could get the same song 10 times. You can't get it on a shuffle, because that's not how shuffle works. But you could randomize 10 songs. So let me ask this. If you took the iPod with 10 songs and shook it, shook it, shook it, what's the chance you would get 10 unique songs in that way? What's the chance? And you actually have the answer, or what you need for the answer, on the board in front of you. You actually have the answer. Actually, now it's off to the side of me, and off to the side of you. Geraldine, go!
Would you divide?
You would divide the answer in part. You got it, girl. You would divide the answer in part. What?
A.
Into the answer in part B. This is the total number of playlists right there, 10 billion. These are all the playlists that have unique songs. So the chance of getting 10 unique songs would be those over those. Is that big or small? Very, very small. That's millions, that's billions. This is extraordinarily small. So if it's extraordinarily small probability of getting 10 unique songs, that means it's a really, really, really big probability of getting the same song somewhere. Right, that's the kicker. The kicker is there's a high probability of getting at least one repeat of one of the songs. It doesn't guarantee. There's actually very, very few iPod playlists that have all 10 songs the same. How many? Kind of a trick question, actually. How many of these playlists right here have all 10 songs the same? Well, on a shuffle, yes, none. But supposing you're hitting a repeat every time, so you could get a song more than once. 10. All Prince, all whatever song 2 is, all whatever song 3 is, all whatever song 4. You see what I'm getting at? So imagine your 10 songs, or 10 different songs, right? One of the playlists would have all of the first song in it. That's one. Then all of the second song in it. Second. You see what I'm getting at? There's only 10 playlists that have a repeat of the entire song for all 10. So that's even more unlikely. And if that happened, you'd think something's broken with my iPod. Because that shouldn't happen. 10 in a billion? The chance is 1 in a billion, or 10 in 10 billion. The chance is 1 in 1 billion. That's ridiculous. That's worse than winning Powerball. Right? Winning Powerball only 1 in 175 million. That's 5 times better odds. 6 times better odds almost. Am I getting out of here? Yeah. So, the chance of getting a unique playlist is basically not going to happen. So the chance of getting some repeats somewhere is pretty much going to happen. And I try this out sometime. How many times have you noticed when you just let those randomizers kind of happen, you get repeats? It has to. It has to, because it can't not, if that makes sense. Does that make sense? It can't not happen, so it has to happen? Sorry, double negatives there, but that's pretty much what we just showed. It's very, very hard to not have repeats. So pretty much it's very, very easy to. Yeah? Good? Yeah, so I'm trying to envision the exam like that, where we've got an iPod playlist. I might use the marching band tracks that I sent you. I might use those, because there's 12 of those. So rather than using 10, I'm going to use 12. Oh yeah, this will be good. I'm seeing it now. I'm seeing if we can link that quiz to this. Yes. Yes, this is good. And I'm not doing that like in an evil way. I'm doing that as writing your exam in my head way. Yeah, Maddie, go ahead.
So when you divide the 10 billion by the 3 million or 3.6 million, and it comes out to 2755.7, what would you write?
Careful. You divide it backwards.
Oh.
You divide that by, you divide that by this, or you divide that into this. You had to hear, I said, divide what by what, and somebody said 10 billion. And I said, yes, divided into what? So that's the denominator.
Oh.
This is your numerator. Right?
What the hell?
That's your denominator, this is your numerator. And it was how I had to say it backwards because of the number that somebody counted 10 billion at first. I was like, yes,
Yeah.
divide it into what
I was
number?
going to say that makes no sense.
No, it doesn't make any sense. You can't have a probability above 1.
Yeah.
Right. So what it ends up being is you take this and you move it 10,
Yeah.
10 move the decimal
I get
place.
it, yeah.
So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There.
Yeah.
That's the chance. 0.00036. That's the chance of getting a unique playlist of unique songs. Highly unlikely.
I just needed to clarify that.
Oh, no, that's good. And I should have known that saying it the way I said it, it's basically backwards of the way you're used to hearing it.
Yeah.
But I wanted to go with the 10 billion that I heard.
Okay.
So divide that into the 3.8 million.
So it's like taking the 3.6
Check this out.
million,
That number you
diving
got?
into 10 billion.
You still got that number in your TI right there, Matt?
Yeah.
Press the button that says X next to the -1 power. And then press enter. And you should be
Oh, there you go.
0.000. That's the reciprocal button,
Mm-hmm.
and it just flipped it, which means you got the correct decimal now.
Oh, that's cool.
Pretty sweet. Yeah.
What'd you say to press?
Yeah,
There's a button on your TI called the reciprocal button, X to the -1 power. Fire it up here so you can see it. Hang on
Right
one
under
second.
matrix,
Yeah, that sounds right. That sounds right, Lynn.
Under map.
It's got its own button. So what happened? Hang on a second. Oh, here we go. So it sounds like, and I apologize for I said the correct English phrase, but it's not the most common mathematical phrase. I said you divide 10 billion into the 3.8, but if you didn't hear that right, you would have gone 10 to the 10th divided by 10 factorial, and you get this number that's too big, obviously. So,
There's an actual factorial.
oh, show you in a second. So to flip it, you can either redo the mathematics, or just press this button right here. You see my finger down there, friends?
Bang.
It's this guy. See where the math button is? Here, I'll slide it up here. It's right under that. Mine's worn off, but it should say X to the -1st power. And if you remember from algebra classes, which it sounds like most of you are trying to forget that, that's okay. It's okay. But when you raise something to the -1 power, it takes the reciprocal of it. You might not remember that. It's totally fine if you don't. So, like, X to the 1st is, or 2 to the 1st is 2. 2 to the -1st is 1/2. It's the reciprocal. And it's a function of the dividing by the base. So anyway, you just take your result that you got up there and press that X to the -1 button. It says answer to the -1st, which means reciprocate, and then you press enter and boom, that's the number that it should be.
Where's the bang number?
Oh, well, that's what Lynn just asked you, Sarah Lynn. So if you want to get that bang, so like I put 10.
It was pretty much headed that direction.
Call it a day, man.
I just realized this should be pointing at the screen too to see anything useful. Thank you, Lynn. Thank you. She's here all week, ladies and gentlemen. She's here all week. Everybody is a waitresses. Just married. Anyway, to get that, you put the number you want to bang first. So I want to bang 10. Press the math button. You've been pressing the math button a lot this year.
somebody better take his picture, he's getting blushed up there, isn't he?
At the Catholic school, sister. Can't make me blush. So, you're in here. Remember when we go to the PRB menu sometimes? I've had you guys go over there occasionally. You go over to PRB, and it's the 4th guy down. You guys have predominantly been using this 5th option right here, the rand int. I've actually used that a few times on quizzes and in class. It's right above it. It's the 4th option. And then you hit strike enter, and that just does the 10 times 8 times 7 times 6. And times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Boom.
Okay, so question, Sean, so there.
Yes, ma'am.
These problems, like we've been doing with
Yeah.
fundamental counting principles.
Yes, ma'am.
They can we do them in the TI?
You can.
I mean, other than the basic math.
You can. There's no advantage to, honestly. The only ones that are slightly advantageous to do in the TI, and, well, I'm going to say why you don't want to, are the ones without repetition. The ones with repetition, you have to basically enter it as 10 cubed times 26 cubed. These without repetition are technically called permutations. And the Powerball are technically called combinations. So for example, these guys right here, this Q2, this quiz 2, where you take 10 digits without repetition, you take 3 digits from 10 without repetition, and then you take 3 from 26 repetition. Here's the TI shortcut, if you will. Here's how this would look at a TI. You do 10.
Is that in PRB too?
Yes, ma'am. SPR 3 times 26 NPR 3, which, if you notice, is this guy. But honestly, to explain that and why it's working, I don't think it's worth the time. It's much easier just to do this. I'd rather keep it looking like the other one. That way, it's less memorization. You're applying one principle over and over and over again.
That's fine.
But you can do it that way.
NPR, what does that stand for?
Permutation.
Permutation.
Now, permutation is an ordered unique set of digits or characters. A combination is an unordered unique set of characters. So, and we'll get into Powerball after break if you guys want to. We'll do a couple. We'll crack a couple of those Powerball examples if you want. Like we do it on Tuesday. We'll do a few
Can
more
we
of those.
ask a couple questions about the homework?
Oh, for sure. Why don't we take 5 minutes, take our break, and then come back and ask some more questions, for sure? Yeah, we'll do some homework as well. The homework is more like your exam for next week, the in-class part.
Yeah, that's why I want to ask.
Yeah, for sure. Let's do it.